On today's episode of the Ag Irrigation Collective, we're going to take a look at pivot track management. Stick around. Hi, I'm Wes Schaefer, your host with the Ag Irrigation Collective. Sure appreciate you stopping by and visit with us today. We're going to go through a study that Utah State University out of Logan, Utah conducted that was called the Guide to Pivot Track Management. And this guide is actually pretty interesting. And those of you with pivots or have interest in learning about pivots, this could be a pretty interesting podcast for you, and I hope it's helpful to you as we dig in and look at this. Some of the folks that were involved with this guide put out by Utah State University, and I'll actually link to this in the show notes and the description of the video here on YouTube. One fellow that I'm quite familiar with, he's Matt Yost. He's agroclimate specialist with Utah State University. There is Benaz Malloy, that's an assistant professor at Tennessee State University that was involved with this. Troy Peters from Washington State University Extension, that's an irrigation specialist there, is also involved. Clara Anderson, that's a research assistant at Utah State University. Burdette Barker, Utah State Extension irrigation specialist. John O. Holt, that's a Utah State University student or former student, and Dustin Larson from Wish Northwest were all involved in producing this. And there's a bunch of, at the end of this, references and different things. It's basically a white paper on Guide to Pivot Track Management. I think there's one thing that we need to kind of keep in mind as irrigators and farmers and equipment dealers. There's two different things. There's deep wheel ruts and there's pivot tracks. And I don't know that we're ever going to do away with wheel tracks in the field unless we have some type of hovercraft drive unit. But wheel tracks and eliminating basically the crop from where the wheels drive is never going to happen. Anytime we drive in a field, let alone a wet field, you will not be able to grow crops on those wheel tracks. And I think we all pretty well know that, but I'm saying that mainly for, our listeners to the podcast and the video here that are completely unfamiliar with pivot irrigation and irrigation on farms in general. So hopefully that will be a little bit helpful for some of your newcomers here. But this mainly goes into some deep wheel ruts that really can cause trouble regarding that. So deep wheel tracks can cause over-irrigation because the pivot moves slower than intended due to slippage. When you get those deep wheel ruts and some pretty heavy mud, specifically depending upon your soil types, and I think we're going to get into that a little later on this document, that your wheel ruts, you can cause slippage, and let's say you want to run around and it should take you, let's call it 96 hours to get around a pivot field. And it may take you 110 hours based on slippage if it doesn't get stuck. And so anyway, also your deep wheel tracks can cause damage to your pivot. I have seen specifically in some of the northern areas where it gets quite cold. And when I'm talking quite cold, I mean in the winter times, you're into negative temperatures for multiple days at a time, below 0 degrees Fahrenheit. Those temperatures can really cause the steel to contract. And when that steel contracts and your wheel and your drive unit is stuck down in a deep track, deep wheel rut, there's nowhere for it to go other than to start tearing metal apart, tearing your structure of your pivot apart. So these deep wheel tracks certainly cause damage to the pivot. But then also you have to consider the equipment that has to cross those tracks. That also includes your swathers, your hay mowers, your semis that are hauling the hay, all the loaders that are picking up hay, any corn choppers, cotton machines, any type of machines that you're running through these fields. And I'm mostly familiar with alfalfa and corn is why I reference those to begin with, and even your pickups as you're driving out to the pivot point to maybe service your pivot or something, these wheel tracks cause trouble for that type of equipment. So How are wheel tracks created? Well, that might sound kind of obvious, but I'm going to go into it. For those that are less familiar, like I said earlier, we have quite a bit of newcomers that are here to learn about farm irrigation. And by the way, we appreciate all of you being here with us. So the sprinklers close to the towers get water into the wheel tracks or wet the surrounding soil even, that then it infiltrates into those tracks. One study showed that up to 3 times the amount of water sprinklers applied to the ground enters the wheel track because the water is intercepted by the tower running through it. And so that's a ton of water going into those wheel tracks. And then the problem is compounded in perennial crops like alfalfa, where there's no annual tillage that fills the wheel tracks. And a lot of times, and we'll get into this certainly later in the document, that a lot of guys are not farming their wheel tracks anyway, even if they are taking out, say, corn once a year or soybeans or cotton. But with alfalfa, those wheel tracks are remaining untouched for between 3 and 7 years at a time. And depending on farming practices, I've even seen guys leave alfalfa in longer than 5 or 7 years. Although wheel track rutting can be a problem in all soil types, clay soils are the most prone to rutting, as clay soils lose their bearing strength when they're wet. Sandy soils are the least impacted because they maintain more bearing strength when wet. And I've noticed that when you have to dig, say, a trench by hand or a hole, if you have a water leak and you're digging by hand, if it's sandy soil, it is so much more fun to dig in than clay. Clay really breaks down when it gets wet. So there are, of course, potential solutions that are outlined in this document by USU. There's actually 5 of them. We'll go through them. I'll tell you what they all are right now, though. The first one is to decrease the pressure on the wet soil by increasing the contact area with the soil. Sounds simple. We'll get into how we can do that. You can modify the soil structure. We can keep water out of the wheel track. Well, that one's actually a pretty good solution. We can fill the wheel tracks. Another good solution. And lastly, you can modify the irrigation system. So the first one, decrease the pressure on the soil, which pressure is weight per unit area, which under a pivot in the United States, we measure that by pounds per square inch, or PSI. Since it is not possible to decrease the weight of the pivot, the best way to decrease the pressure on the soil is to increase the soil area that is bearing the pivot's weight. Here's some ways to do that. You can use larger wheels and tires. By increasing the tire size, both in diameter and width, more tire surface area is in contact with the soil, reducing the pressure on the soil. This is often referred to as flotation. Larger tires increase the load on the driveline, requiring higher torque, and can increase the risk of drive motor and gearbox failure, though. So you need to keep that in mind as you start throwing these gigantic monster truck tires on your pivot. You could run into some other troubles with your drivetrain. Larger tires are also more expensive than smaller tires. So there's some cost considerations as well. You can lower your tire pressure. Tires with lower tire pressure also move more surface area in contact with the soil than wheels with higher tire pressure. Lower pressures result in more sidewall flexing, which can be detrimental to tire life and function because of cracking. Do not use a lower pressure than the minimum recommended by the tire manufacturer. So if a lot of pivots I know with irrigation rated tires, they're running around 18 PSI on some of these pivots. And that seems to be a pretty good flotation, and that's namely on 14.924 size of tires. So a third way to lower the ground pressure with your pivot is add additional wheels and tires. This can be quite a costly way to do it, but it increases the tire area in contact with the soil, which decreases the pressure on the soil. Some pivot manufacturers allow adding a third wheel in the middle of the tower. There are a few different ways to add a third tire to the tower. It can get pretty costly. They're between $3,000 and $4,000 a tower to convert an existing machine, and if you add it onto a new machine when you order it, you're about $2,000 per drive unit to add the third wheel. I know with Valley pivots, they call it a 3-wheel base beam. I'm guessing it's something similar to that with the other manufacturers. But it would result in about a $14,000 additional cost for a new 7-tower machine, or up to $28,000 to retrofit an existing machine. Of course, get with your local dealer for pricing on that. Those are just estimates that USU has put out, which they do call around to other pivot dealers to get quotes on these. So I imagine they're not far off. But anyway, so that's pretty good. The fourth one on that is to adjust the wheel configurations. Some pivot wheel configurations spread the weight out on the soil by creating a flatter surface that is in contact with the soil. Be aware that the solid style tires and wheels increase wear on drivetrain components. Having a rubberized tire provides cushion to the drivetrain, and irrigation dealers have noted that plastic tires claiming to reduce rutting often do not work well. There are some. There's one that's a bright green color. I do not remember the name of the company that produced those, but those tires, there's no flex to them at all. They're just a solid plastic, like a hard plastic, and I have not ever seen any instance where they have reduced rutting necessarily. Now, they may keep your machine from not getting stuck in the ruts, but I have not seen any reduction in ruts based on the hard plastic. So there's several other styles. There's like I think it's called a raft track. That's like a paddle-looking big conglomeration of stuff over your tire, and it does actually work, but you have to change a gearbox, and you're going to be fighting that whole conglomeration the entire time that you're out in the field. And typically when you're changing those, a couple of things, you're in a hurry, it's muddy, and you got other crap to do. So weigh your options there. So our next thing after lowering the ground pressure, that we can change the soil structure. You can use a polyacrylamide soil conditioner, which is called PAM. I've heard it called soil PAM. And what it is basically is in a mesh bag that you hang from your drive unit right over top of the wheel track. And when those sprinklers spray onto it, it drips this polyacrylamide into the wheel track. And I'll tell you kind of what it does. They've written it out here. PAM also can increase the soil infiltration rate, as it has been commonly found by researchers. There's been recent interest in using PAM, which is polyacrylamide, to stabilize the soil and wheel tracks to reduce rutting. Irrigation dealers and agronomists are marketing PAM in powder and log forms. So the type that we sell at our dealership are in somewhat of a log form. They're more in like large pellets, or kind of like hay cube size of cubes. The estimated cost of using PAM on each tower of a quarter-mile pivot in 2023 was about $100 per year, because over time this will, as it drips down, those logs or those cubes diminish, and you do need to refill those mesh bags. One potential challenge with PAM is that potential infiltration increase in the track could cause more water retention and subsequently cause deeper tracks. So in recent research trials at USU, which is in Logan, Utah, PAM has had little or no impact on rut depths. So they found in some of their trials that it has not been effective. Number 3 is to keep water out of the wheel tracks. Soils, especially non-sandy soils, lose structural strength the more wet they become. Wheel track rutting can be significantly reduced if the soil is kept dry enough when the wheels traverse it. There's several methods to keep the water out of the wheel tracks to avoid deep ruts. Here's some of those methods. You can use a half-circle sprinkler. There's one challenge with a half-circle sprinklers, then you have to have a rigid drop. Because if you put a half-circle sprinkler on a hose with the pressure and the velocity that water is coming out of that sprinkler, naturally it is going to push that hose, and what it ends up doing is then your pattern sprays down into the ground instead of out into a pattern. So a half or a part circle sprinkler can be used next to the tower to throw water behind the pivot's travel direction to decrease the amount of water falling into the wheel track from sprinklers or from interception by the tower. But by using half-circle sprinklers, it can reduce the water distribution uniformity if it's not designed correctly. So you do need to design those packages with that in mind to be able to use a part circle or half-circle sprinkler, so you're not losing too much crop yield around those. There's another method called an offset sprinkler boom or a boom back. You know, it's interesting. We've got a group on Facebook called Pivot Irrigation Troubleshooting, and I brought up boom backs at some point several years ago, and there's certain regions in the country who have never heard that term of a boom back. And so maybe some of you listening to this podcast will have not even heard the term of a boom back. So I'll go into what they are. So an offset sprinkler boom or a boom back is 2 or 4 sprinklers located adjacent to the towers. So typically you have your drive unit, and then on each side of that drive unit from your outlets off of your span pipe, you either use 2 or 4 of those outlets to put these boom backs on. And they are basically, I think they're a 15 or 12, 15 or 18 foot length of galvanized pipe that basically puts the water clear out behind your wheels. So it's offset on booms behind the wheels that go clear back, and then in conjunction with those, you also can use part sprinklers shooting back away from the wheels to further keep it off. And since the boom backs throw the water behind the moving tower, there is also less water intercepted by the tower to drip into the wheel tracks that can result in improved uniformity for the sprinklers. Another method there is that you can modify your span pipe drain. At every drive unit, on all the pivots that I'm familiar with, which would be Valley, Zematic, Ranke, T&L, Pierce, all of the modern pivot brands at every drive unit have a drain. Some of them are a spring drain. Some are called a spider drain, which has a rubber puck in them. And those are located basically right above the wheels because that's the low spot on the span. Many pivots have a span pipe drain valve that is located at the lowest point of the pipe next to the tower. The drain water can flow directly into the wheel track by having them there. So one thing to do is you can connect a drain hose, or even you could use a rigid pipe, I've seen both, and bring it down and then tee into your nearest drop hose where your sprinkler is above your pressure regulator, and the water can then drain out of your sprinkler well away from the wheel track. And another thing too is you want to also be sure to perform maintenance on your drains, because those in good working condition will only put water into the tracks on startup and shutdown. This is one of the maintenance items that is often overlooked and results in water always draining into the wheel tracks. The fourth way is to remove the sprinkler next to the tower. Some growers simply remove the sprinklers next to the towers or turn them off. This helps reduce the amount of water hitting and wetting the wheel track. There's often yield loss due to water stress of the crop growing next to the wheel track. So you do lose some crop. And as you look at pivot fields, as you're driving around, you can see whether the crop is shorter or non-existent right up next to the wheel tracks under some of these scenarios, and that is because they have taken measures to eliminate the water around those wheel tracks for very, very good reason too. So you do have to kind of weigh your point of diminishing returns, though, because if there's a point where you're losing too much crop yield, then you're out of money on that end. But if you're tearing your machine apart or tearing your stuff up, are you having to spend too much money maintaining your machine? So there is a point of diminishing returns that you need to kind of take into account here. So number 4 is to fill the wheel tracks. Wheel tracks can be filled in by tillage operations in an annual field crop. So, for example, with corn, if you're going in after you harvest your corn and doing some tillage operations, you can go ahead and till in those tracks. Tracks can also be directly filled with soil in perennial crops or during a season if necessary. It is also possible to fill the tracks with materials that give the soil additional structural strength, such as sand, gravel, and straw. So fill the wheel tracks with gravel. Many growers add gravel to their wheel tracks. One thing that I've been mentioned to me over the years, the minute that I tell guys, fill your tracks full of gravel, get some good gravel in there, make a nice base, and it'll make everything nicer. The first comment that gets said to me is, I spent my entire childhood taking rocks out of the field. I am not about to put rocks back into my field. And that's okay. That's okay. If you don't want to do that, phenomenal. Keep the gravel out of your field. There are some other methods here. So putting gravel in your wheel tracks can be a long-term fix that is quite effective, as gravel creates structural strength and allows water to drain through it. It does require careful tillage operations afterward to keep the gravel in the tracks and avoid spreading it to the rest of the field naturally. It usually means tilling in a circle to avoid crossing the wheel tracks. Filling tracks with gravel can be highly effective. However, it is expensive. It does permanently alter the field, and it often dictates how you must conduct future field operations. I've even seen fellows that have nice gravel tracks in their pivot field, and let's say the pivot crashes and they want to, for whatever reason, change brands of pivots. And their span lengths and where their wheel tracks are located now in the field, unless you want to go tear that gravel out, you're stuck with those span lengths. So that's something that you need to consider off into the future, which I know it's hard to see out into the future that far. But it has been a real issue that I've been very familiar with, that a guy, let's say he's going from a Ranke machine and wants to try a Valley machine, and he now has Ranke span length set up in his field that he, without tearing that gravel out or rechanging some of his wheel tracks, now either has to stay with a Ranke or has to do something different. So anyway, there's some of those considerations to take into account. You can also fill the wheel tracks with soil. Filling the wheel tracks with soil and then compacting and flattening the soil with a terrace blade, road grader, or a check bank crowder can prevent water from pooling in the wheel tracks and ruts forming. I have seen fellows that will, with soil, build up and make somewhat of a hump or a dike or an elevated surface for the pivot to travel on. And once you get that built up and can talk the water into draining off of it, that is more helpful. However, with the weight of the machine that is full of water, those machines are heavy, and so you run into some issues there. You can also fill the wheel track with straw. Straw added to wheel tracks will mix with the mud as the pivot tower wheels pass over it, giving the soil additional structural strength. Using netted straw can help fill the wheel tracks. So I've seen both of those used in some real bad areas. I've seen guys take cinder blocks, whole cinder blocks, and set them in where it almost seems like if you put gravel in, if you put straw in there, that it just keeps going down and down and down. And they'll put cinder blocks in there, run over them with the pivot. Of course, it crushes the cinder blocks. They'll put more in there. I've seen that be effective. There's several different ways to do that. So the last thing on here is to modify the irrigation system. And going into that, the first one there, by modifying the irrigation system, basically it's going to utilize different types of sprinkler packages. The first one is mobile drip irrigation, or MDI. So mobile drip irrigation is when a center pivot drags drip tubing with integrated emitters along the length. The drip water is applied behind the pivot. It keeps the wheel track dry and thus decreases the wheel's track depth. With MDI, or mobile drip irrigation, no water scatters directly into the ruts. MDI is pretty good if you can keep your water filtered. Filtering your water, just like any drip system, is imperative in order for that type of system to work. They are very effective for lack of wheel ruts, but that is a problem you run into. Excuse me. Okay, the next one after MDI, you can get into something like a LIPA, which is low elevation precision application type of sprinkler package. And what LIPA does is it dribbles water directly onto the soil and is positioned closer to the ground than mid-elevation sprinklers, or MISA. Because of this, the grower has more control over how much water makes it into the wheel tracks. In a recent Utah State University research trial, LIPA, or low elevation precision application, did show the best potential for maintaining yield and crop quality compared to other options with MISA, which is mid-elevation, as well as minimizing water entering the track to reduce ruts. To help reduce water running into the track, the LIPA sprinkler nearest to the track can be used as a bubbler pad to reduce the water spraying on the track. So there are some management type of methods of what style of sprinkler you use right next to the track, and the height of the elevation of those sprinklers are beneficial as well. So many options are available to help reduce the impact of pivot ruts on irrigation efficiency and crop yield. Methods can generally be categorized as those that decrease the pressure on wet soil by increasing the contact area with the soil, keep water out of the wheel track, fill the wheel tracks, and modify the irrigation system near the tracks. So irrigators are encouraged to explore each option, consult with irrigation suppliers and dealers, and trial as many options as available in your area, and then scale up to the options that work most effectively. And so, I mean, there's a few ideas in here. A lot of them are great. Some of them are far more expensive than others. Some are nearly $0. You may already have gravel on your place. You may already have whatever, but there's a lot of different methods and a lot of different things to utilize with this type of program. So I hope this is helpful to some of you, and I hope you can share this around to your friends and neighbors, and maybe subscribe if you find this beneficial, and we hope to catch you on future episodes. Sure appreciate you stopping by with us today. Be profitable, my friends. We'll catch you on down the road.